This is the first of our 3 jump instructions, which allows us to change the order of the program execution. So let's look at the first of our 3 jump instructions. So the idea here is to change the program execution. So instead of the program running sequentially from one memory location to the next, so memory location 1, 2, 3, 4, 5, 6, 7, 8, so on, what we want to be able to do is we want to be able to jump about from memory location to memory location. So for example, we maybe want to get to memory location number 7, and then the very next data instruction we might want to come from memory location number 12, and then the next one might be memory location number 2 and number 19. So it just means we can jump about the memory locations. So this is called jump register, and what it does is it jumps to the address which is given in the register RB. So it's GMPR, jump register RB. So in this instance here, the register is given by regB, and we've chosen register 10 in this example. So we could say that this is jumped to the address given in register 2. So quite simply we can say that it jumps to the address in RB. So the jump register instruction is given by 0011. These 2 bits aren't used, and the register that we're going to hold our jump location is going to be register RB, which in this instance here is going to be given by register R2. So the best thing to do is again see it by example. We'll go and build it up in Logisim and we'll test it out. So if you head into the resources section, you'll see the file called jump register instruction. So come down and double click on the CPU, and again we've seen this before in the previous several videos. Now I'll zoom in, we'll have a closer look at that. Okay, so this is our top level of our CPU, and you'll see here that I've disconnected the instruction register because we're going to put our own instruction in. So the instruction we're going to put in for the jump register is going to be 0011. These 2 bits don't matter, okay, they're not applicable, and the last 2 bits are for our regB, and those are going to be, well, we're going to choose the value 1, 1, which is register 3, which is this register here. So really what we're saying now is, instead of the instruction address register getting its next address via the accumulator, the instruction address register is going to get its next address from this register here. So we can put a value in for the next address here. So if we wanted to, we just put any value in. Okay, we'll put all 1s. Okay, so it means that the next address the instruction address register is going to go to in the execution cycle is going to be address number 256, which is the very last address on the RAM. So let's go ahead and we'll see how this is done inside the control section. So here's the control section here. We can see here that the value 0011, which is going to be used for the jump register instruction, we see we've got a 1 1 here, so that's choosing the 4th AND gate down. So that AND gate there, pin goes live, and it's waiting for position 4 to come live. So whenever position 4 comes live in the stepper, then this line here is going to come live, and all this line is going to do is it's going to enable regB onto the bus, and it's going to put that value into the instruction address register. So that's quite simple, it's just putting the value of the register into the instruction address register. So let's go ahead and we'll see that actually working. So we can back up to the top level. And we can see here, we'll go through the clock pulses. So we get to the 12th clock pulse. So there's a 12 clock pulse there, and we come down into the control section, and we've got our Reg B has been enabled. So we come down here, there's our Reg B, it's been enabled. So we're dealing with these AND gates here, and you can see from the choice here that we've made is 1 1, which is register 3. So we're taking the contents of register 3 and we're going to stick them into the instruction address register. So we go up to the top. So there's the contents of register 3, which are all 1s. It's all going onto the bus, and we're going to set that in the instruction address register. So whenever the set goes high here, that's the set going high, that's set high, so now that value 1 is in the instruction address register. So it means that the next instruction that the CPU executes is going to be in byte 256 in this RAM. So that's quite straightforward. We're going to go and look at another 2 jump instructions over the next couple of videos. So thank you for listening, and goodbye.